In this video, we're using the law of exponents to simplify each expression. Looking at expression A, I can see that they're dividing x to the third times y to the fifth by x to the fourth times y to the second. So I see that the problem involves division, and we have common bases here for the term. So what I'm going to do is simply this. I'm going to isolate sort of the pieces that involve the x's, right? I just look at that alone. I'm dividing two terms with a common base, and it says that I should keep the base when dividing common bases and subtract the exponents. So it'll be literally 3 minus 4 for the x piece of the problem. Now for the y piece, it's the same thing, right? For the y piece, I have two terms with a common base, so I'll keep the base, and I'll subtract the exponents, 5 minus 2. If I clean that up a little bit, it'll just be x to the negative 1 power and y to the third power. Now we don't like negative exponents, so I'm going to write this over 1, and then I'll move the x down to the lower level so that it becomes something with a positive exponent. So we'll end up having y to the third over x, and that is the solution. Now there's another way we could have tackled this problem. I'm just going to show you that for this one because it would work pretty well for this one. Okay, so looking at expression A one more time, my strategy is going to be a little bit different this time. What I'm going to do is anything that has a common base, I'm going to try to get them together on the same side of the fraction. So I want to move, for example, either the x to the third down to be with the x to the fourth, or vice versa. I want to move the x to the fourth up to be with the x to the third. But here's the thing. I think I'm going to move the x to the third down below because it has a smaller exponent. Because what's going to happen when I do that is I'm going to end up having y to the fifth on top, and I'll have the x to the 4 on the bottom. And when the x to the third comes down, it's going to be multiplying, but it'll be x to the negative 3, and it'll be multiplying that x to the fourth, right? So the x to the 3 comes down and ends up becoming x to the negative 3. Remember, when you cross the line, you change the sign of the exponent. Likewise, if I bring this y squared up to the top to join the y to the fifth, because it has a smaller exponent, I'm going to move it. And when I move it, it's going to become negative 2 up top. So it's going to be y to the third on top, because 5 minus 2 is 3. And on the bottom, it's going to be x to the 1 power, or just, in other words, y to the third over x, which is the same exact answer we got before. But the difference is that we approached it a little bit different. We moved the terms to where we wanted them to be, and then we simplified using multiplication as opposed to using the division rule. They're exactly the same, and they're logically equivalent. It's just that some people find in some instances the second way we did the problem easier, and in other instances the first way is easier. So let's look at problem B, and we'll illustrate that sometimes the first way is easier. The first thing we see is this negative 1 to the fifth power. Remember that anytime you're raising a negative number to an odd power, the answer will be negative. So we know it's going to be a negative something, and of course 1 to the fifth power is just 1, so negative 1 to the fifth power in this case will be negative 1. Okay, from there we'll just copy down the x squared that's next to it. And we have this now expression where we have the y squared and the z in parentheses, and we have the 3 on the outside of it. So what we're going to do is bring in the 3 using that rule that says when you're raising a term to power, you multiply the powers or multiply the exponents. So it'll be 3 times 2 to give us y to the sixth. And then we're going to have 3 times this z will be to the first power, so we'll have 3 times 1, and that'll give you z to the third power. All right. Now once that's taken care of, then in the denominator we simply have 2 to the third, which we can say is 8, because 2 times 2 is 4, times another 2 is 8. Then we have the x, the y to the fourth, and then the z squared. Now here it's probably simpler to just use the normal rule for division, which says that we're able to keep the base and subtract the exponents. So if I have in the front negative 1 eighth, then it'll be x to the 2 minus 1, because the common base of x, right, in each piece is going to divide by subtracting just the exponents and keeping the base. If we do the same for the y's, we'll end up having y to the 6 minus 4. And then for the z's, we'll have z to the 3 minus 2. So again, keep the common base of y, subtract the exponents, keep the common base of z, subtract the exponents. And when you're finally finished with this problem, you end up with negative 1/8. And in the numerator, you'll have x to the 1 power, y to the 2nd power, and z to the 1 power. And that's the solution to this problem.